Good morning. Welcome to our first day of college algebra together. Looking forward to seeing you guys' pre-tests. I've already got some sent to me and a couple turned in via Blackboard. That's great. Make sure I get those by tomorrow night at 11:59 p.m. That way I can get those grades updated as soon as possible and help provide a better direction to go in for how we're going to be approaching some of our lessons for the coming weeks. We're going to start off with a lot of basic talk, and many of you guys have taken, Algebra 1 and Algebra 2. Hopefully, you should pass those classes. So, for the beginning week or so, a lot of this material is going to feel very, very basic. In fact, if I was to tell you the secret truth, college algebra is a rehashing of Algebra 2, going more in depth to some of the topics. And so if you've taken Algebra 2, you're not going to see a lot of new material in college algebra. What you will see are new approaches, new methods that work better, or allow you to find new solutions to problems that before were unsolvable with the more basic things that college algebra tended to do, or that Algebra 2 and Algebra 1 tended to do. And really, that tends to be a theme as you go farther in mathematics. You will find that the farther you go in math, the more you'll see basic topics from previous classes investigated more in depth, and seen as a stepping stone to understanding bigger and greater things. Now, in our study of these topics, we will always start small. I will move quickly during these first couple weeks, because for many of you, this will be too basic. You already have these skills. But do note that a lot of my time that I'm going to be talking about these is going to be spent discussing the theory behind them, why they work, what makes them work, rather than what has typically happened in many previous classes, for at least my experiences, is that in Algebra 1 and Algebra 2, you are told, here is the method, do it. That puts you at a disservice if you wish to go farther, because while learning how to do something is important, knowing when and why to do it is what separates a master level person from a amateur level person. Put it in terms of something that I love to play football. Knowing how to run a play is one level of difficulty, but knowing when to run that play versus a specific defense, or how it will fit against this specific line that you have, is a totally different thing. Any team can run a specific play, but how successful that play is dependent upon other outside factors. And mathematics is the same way. There are rules and methods that work in mathematics that you can just learn and apply and be fine. But if you wish to go farther, which I hope is the purpose of you taking a college algebra class, I know some of you may be stopping after this class. This is your last math class. But for many of you, this will be a jumping stone into trig or calculus. If that is the case, you need to start asking more questions about why does this work? Why does this method apply in these particular circumstances? Because if you don't understand the answers to those questions, you will always be limited compared to someone who does. So let's start with some basics stuff and then see how we go from there. As I said, the first couple weeks will be very, very basic, and we'll see how we like it from here. So you'll often see me in this mode. I'd like to do my notes with you guys so that you can kind of see how I work and how I think. This gives us a great framework, and you can always at any point in time pause and take pictures of my notes and use them for yourself. I write my notes the way a mathematician writes their notes, brief, systemic, to the point. So if you ever find that you need clarification on something, that'd be a good thing for those Zoom sessions. Make sure you fill out that survey, as we will have our first Zoom link on Thursday to answer any questions. Okay, let's start with something really basic, something that's so basic that it's taught in elementary school: order of operations. Now, for many of you guys, order of operations is so basic in level that determining how to do order of operations should be second nature. But for others, there can often be some distinct confusion. Sometimes you do it right, but sometimes you make simple mistakes, where you'll get a different answer and then be like, oh yeah, I forgot this one case where it doesn't work quite right. And usually that stems from not fully understanding how order of operations is intended to work. Let's remind ourselves of some things. Order of operations is often abbreviated as PEMDAS. What this means is you have parentheses as the first thing you should look to try to simplify. Now, for my math classes, I spend a significant amount of time discussing vocabulary. Because if you don't understand the phrase simplify, then when I say we use order operations to simplify something, I've just spoken a foreign language. You don't know what I mean. And so it becomes confusing at its basic level, which means it's hard to do it. So when I say simplify, what I mean is to reduce complexity. To reduce complexity. In other words, instead of having 5 constants in a problem, I have 1 constant in a problem. Instead of having 3 variables in the problem, if possible, I should reduce to 2, or even 1. That is an important note to make when you're looking at something like an equation, because the more you can simplify something or reduce its complexity, usually this will lead to easier math. Now, in lower level math, we think of simplifying as the math, but really, this is because we're thinking of something called arithmetic. Now, arithmetic, if you happen to be a fan of Harry Potter, as I was, arithmetic refers to manipulating numbers. You know, if I write a phrase like 5 plus 7 times 2, this phrase is arithmetic. It's not actually math. Arithmetic is a smaller branch of math, a subcategory, if you will, where you are looking to take numbers and reduce their complexity through simplification. So we do this via order of operations. And what order of operations does is it provides a framework that guarantees the same answer for everyone. That's a big detail that is often underutilized in lower level mathematics. The whole purpose of order operations is that we get the same answer. That if we look at a problem, such as our first problem today, that we'll work on together, 3 times 2 squared minus 4, 6 plus 2, that if we look at this problem and attempt to solve it, we will get the same answer. That's its sole purpose. There is no greater theory behind this. The entire purpose of order operations is that when we get to the answer of this problem, we all agree that the answer is the same thing. And it does so by using these 6 supposed steps. Now, 6 is a broad term here, because it turns out there's actually a mistake. Now, exponents refer to any powers, and these are typically done second. Multiplication and division are done together, and these are usually done third. Addition and subtraction are usually done fourth. What that means is if I look at something very basic like 5 plus 7 times 2, I go, starting with the first one, and ask, are there any parentheses that I could apply operations to? And note, all 6 of these things are referred to as operations. These are methods by which a number or variable can change. So parentheses is an operation. Exponents are operations. Multiplication and division are operations. Addition and subtraction are operations. They affect a change in either a variable or a number, or a variable or a constant. So let's take a look at this example. What this tells me is that in this particular problem, I need to follow a specific set of steps to guarantee we'll all get the same solution. The first set of steps is parentheses. So you notice that there are 2 sets of parentheses in this problem. And what the P in PEMDAS stands for means do parentheses first. Meaning I am supposed to take this function, and anything that's in a parentheses, I should see if it can be simplified somehow. How do we simplify? By applying other operations. So inside of these parentheses, there might be other parentheses, or exponents, or multiplication, division, addition, subtraction. We don't know, but we need to put parentheses done first so that we all agree upon an answer. So inside of this first parentheses, you'll notice how there is 3 times 2. Now, multiplication is third in line. And you'll notice there's a square on the outside, which is second in line. So shouldn't I do the 2 first? The answer is no. Because it's in parentheses, the parentheses is done first, meaning I skip over the 2, which is outside the parentheses, and I basically restrict my problem to just this piece, 3 times 2. And I can do any of those operations up here in that set. And so for this problem, I can take my 3 times 2 and get 6, which is still in parentheses, and square it. On the right-hand side, Again, I have 6 plus 2. Now this 4 is being multiplied with the parentheses. Now if you know some more advanced properties, which you all should, you might know that you can do other things first, but I'm going to stick to basic order of operations. What that tells me is what is inside this parentheses is treated like its own separate problem, meaning that 6 plus 2 is the only operation I need to be looking at right now because I'm doing parentheses first. So I look inside the parentheses, I see 6 plus 2. 6 plus 2 is 8. Which means I end up with this first step. This is after my parentheses have been done. Next step, I can do any exponents, which means that any place I see an exponent being applied, I need to do it. Now you notice I left my parentheses here. There always comes a time when parentheses are unimportant. That time refers to whenever there's no operations that can be done anymore. Note what I said. When no operations are left, meaning there are no exponents, there's no multiplication, there's no division, there's no addition, there's no subtraction that can be simplified. Notice how all these definitions fit together. Okay? I can't do exponents until everything in parentheses is simplified, as far as it will go. Okay, but now that I have got this simplified, the 6 in the parentheses can basically drop, meaning I end up with this expression. And these two are equivalent. From here, I can do my exponent property, which is 6 squared, which is 36. At this point, multiplication and division are done simultaneously from left to right. It is not done multiplication first followed by division. It is done left to right, doing both as you see them. So there's 36 minus 4 times 8. The 4 times 8 is multiplication. 4 times 8 is 32. And then the last part is, of course, addition and subtraction, which are again done simultaneously left to right. So 36 minus 32 is 4. The whole reason order of operations exists is to allow us to get the same answer. We should all agree the answer is 4. If we do some other version or make any mistakes, we will get a different answer, and that's how we know that answer is wrong. Because we agree that this is the way we should go, and so if we do it that way, we should all get an answer of 4. Okay, let's move a little faster now. So we're going to do a couple of these. We're going to do B. This one's going to be 5 squared minus 4 over 7 minus square root of 11 minus 2. 5 squared. I apologize. My handwriting is always terrible. I'm a chalkboard person. Okay, let's go quickly through this. So, in this case, let's talk about some things. First, parentheses should be done first. Notice there are no parentheses, but there are something referred to as hidden parentheses. Inside of this square root function, there is a hidden parentheses. On the tops of these fractions and the bottoms of these fractions, there are hidden parentheses. It is important to note that when you look at a operation problem, look for any hidden parentheses. Because remember, parentheses have to be done first. And so if there are any that are hidden, you have to note where they are so that you make sure you do those ones first. The reason this is important is because, well, this tells me that my 11 minus 2 can be done first. And my 5 squared minus 4 can be done first because they're in parentheses. So the top one in the parentheses has two operations being done. We have a square and a minus 4. According to our operations, exponents come first, subtraction comes last. So I would do 5 squared, which would be 25 minus 4. And then here, the 11 minus 2, so they become 9. Now, again, this is still in parentheses, so I can still choose to do that first, meaning that 25 minus 4 would become 21 over 7 minus the square root of 9. So we should all agree that from the first to here is one step. It allows us to take our two operations that are all parentheses, mind you, and get to a solution. From here, the exponent can come next, which would be 21 over 7 minus 3. 21 over 7 is a division problem. Division comes before subtraction, so I'll go ahead and divide. 21 minus 7 is 3, and 3 minus 3 is a subtraction problem, which means my answer should be 0. So you can see that, again, order of operations is meant to be we all get this problem, so we should all get to this solution of 0. That is how you know you've done the math correct. Let's do 2 more very quickly here. C and D. These ones, I'm going to start skipping some steps, because these should be pretty basic problems for you guys by now. 6 minus the absolute value of 5 minus 8, plus 3 parentheses 4 minus 1. And for D, 14 minus 3 times 2 over 2 times 5 minus 3 squared. Okay, let's do it fast here. Other hidden parentheses. So hidden parentheses come in the form of fractions, radicals, you could also do things like absolute values, as we see in this one, which tells me that for this problem, I'm going to have to take some very specific first steps. In this case, this is in parentheses because it's inside the absolute value. And so that needs to be done first, as well as the 4 minus 1. Notice that parentheses have to come first, but which parentheses isn't as important unless there's one inside of another one. If there's a parentheses inside of this other parentheses, then the farthest in needs to be done first. So let's take a look. So I do my absolute value, and into the absolute value I have a subtraction. So I have 6 minus absolute value, 5 minus 8 is negative 3, plus 3, I do my parentheses, 4 minus 1 is 3. From here, absolute values act like parentheses, so we can do that step next. Absolute value of negative 3 would be 6 minus 3, plus 3 times 3 is 9. Notice how I can do 2 operations at the same time, just making sure that I do my parentheses and exponents first. From here, I go left to right, because addition and subtraction are done at the same time. So even though the plus is listed first, the 6 or minus 3 is farthest to left. 6 minus 3 is 3, 3 plus 9 is 12. The point of our operations is that if we are given this problem, we should all agree the answer is 12. D, let's take a look at our problem. I have hidden parentheses here, one sit on top, one sit on bottom, and so I can do the top parentheses as one problem. I can do the bottom parentheses as a separate problem, and then do the division afterwards, because again, hidden parentheses. So 14 minus 3 times 2, 3 times 2 is 6. So I'm simplifying that top parentheses in one step. On the bottom, same thing. I have 2 times 5, which is multiplication, but the square comes first. 3 squared is 9. On top, it's a parenthesis, so I can do anything inside of it in order from PEMDAS. So I can take 14 minus 6 and get 8. On bottom, I have to do order of operations inside this parentheses. So I take 2 times 5 minus 9. I have to take 2 times 5 first, which is 10. On top, there's nothing left to do, so which is an 8. On bottom, we have 10 minus 9, which is a 1. And 8 divided by 1 is 8. Again, order of operations states we should all get the exact same solution to our problem. Okay, let's now talk about the next piece. Again, these are all pretty basic stuff. This shouldn't be too big an issue for you. Do note the few little things that can mess you up. Okay, hidden parentheses can mess you up. Getting locked into, I have to go PEMDAS. No. M and D are done simultaneously, left to right. A and S done simultaneously, left to right. It is the most common way to make mistakes is to lose track of multiplication, division, or addition and subtraction. And then these hidden parentheses are the next most common. Okay, next. There are some properties that are pretty important to know. You're going to see me use a symbol today that you may not have seen in your other classes, depends on your teacher. So let's go ahead and talk about them. There are a total of 5 properties that are pretty important for this class. If you remember everything perfectly from Algebra 1, you may remember all these. If you don't, well, that's okay. Okay, For each of these, there's going to be two different versions. There's going to be a version that involves addition and a version that involves multiplication, which uses the X symbol. Or in my case, I prefer the star symbol. That way I don't confuse it with a variable. So, two different versions. Let's talk about each one. So, the commutative property says that when it comes down to it, order is not important. Now, order is not important for things like addition and multiplication. In other words, if I have a function like a plus b, I am allowed to make the following change. Now, this is the symbol that you may or may not have seen. What this symbol is referred to as is a therefore symbol. What it means is the left-hand side can become the right-hand side. So a plus b can become b plus a if you choose. Now notice that there's no other operations involved. So you have a plus b, it becomes b plus a. And in multiplication, the same thing can happen. A times b can become b times a. And you'll often see another symbol associated with this, which is the reversal. Meaning not only does it work one way, it actually works both ways. And that makes sense. Because if I have a plus b becomes b plus a, then of course if b and a are switched, then the results will be switched. So it all makes sense. These two are very much the same statement. In fact, some people even use an equal sign here. But I don't want to confuse our equality properties with these properties. So, this will be autofocus. There we go. Okay. Associative property. The associative property says is that if you have things like parentheses separated by the same operation, those parentheses can be applied in whatever order you wish. So, a plus b plus c, since they're all the same operation, the order isn't important. And in fact, there's a third version, you can drop these parentheses. And same with multiplication. If you have a times b times c, you may instead write a times b times c. Again, notice that these properties only apply to a single operation. We have only plus on this side, we have only plus on that side, we have only plus on this side, we have only plus on that side, only multiplication, only multiplication, only multiplication, only multiplication. There's only one way this can work is if one operation is being applied. The distributive property is the exception, and so there's two different versions of this one. But they actually mix. This is the only operation that mixes multiplication and division. So you have a times a function b plus c. You are allowed to rewrite it as ab plus ac. And this is the exact same one as over here. And again, this works both ways, meaning you can take a and distribute it to both b and c, which is why you get a, b, and a, c. But you can also go backwards, and this is typically referred to as factoring, where you take ab plus ac and you remove an a from both of them. And so both are allowable, and both are versions of being simplified. Again, if the goal is to reduce complexity, each of these is the same operation, just with different views. The identity property states that for every number in the number line, if you add 0, it does not change the value. And if you multiply, a times 1 will not change the value. So, if you multiply something by 1, it doesn't change that value. So if you take 3 times 1, it's still 3. But this also means that if you take anything equivalent to 1, you can multiply it and it will not change the value. Finally, the last one, inverse. For addition, this is a and negative a. Will get you to the identity element. And for the inverse, a times 1 over a. You'll notice there's an exception here. The a cannot be 0. This is because you're never allowed to divide by 0. Fun fact, if you go farther in mathematics, there are places where dividing by 0 is not possible, but calculatable, which is a different thing. And so that's a really interesting thing. If you wish to go farther, you'll get to learn some of that stuff. It's kind of fun. And so these are your basic properties. These are ways you are allowed to simplify a function, where you can take a function and rewrite it in terms of different forms and see how they fit together. Now, how does that work here? Well, let's look at some examples. A, B, C, and D. These ones I'm less concerned about in terms of your homework, and I'm less concerned about in the class, but know they exist and what they mean. You'll find that I will reference things like the distributive property, and if you don't remember what that means, then you're in trouble. I will reference things like the associative property, and if you don't remember what that means, you're in trouble. These will very rarely be the homework problems, but these will often be steps in the homework problem. Take a look here. I have A, which is 3 times 6 plus 3 times 4. And the instructions might say something like, rewrite and simplify. What this means is, do not solve it the way it is written right now. Instead, rewrite first. And so you can see that the way this is written looks exactly like the right-hand side of the distributive property. Which means that, even though it may seem weird, one way that we could rewrite this function is we factor a 3 out of both pieces, giving us 6 plus 4. Why would you ever do that? Well, eventually we're going to talk about what happens if this is an x, not a 6, in which case this is a logical step. But it works with numbers. That's a big detail to make. So here, I can take my next step, which is I can do anything in the parentheses first, because remember, order of operations, parentheses are first. 6 plus 4 is 10, so I end up with 3 times 10, and 3 times 10 is 30. Note that if we had done this problem in the original way, and done 3 times 6 and gotten 18, and done 3 times 4 and gotten 12, we would have still gotten to 30. But this method is good to train your brain for variables. We will often factor variables and factor numbers away from variables. And so it's a really important ability to be able to see the connection between this line and the line below it as being valid steps. In this case, not the best steps, but that does not take away from the fact that it is a valid step. B. This one, we're going to do 5 plus 8 plus negative 8. Now again, in purple, I'm going to showcase kind of what the operations say is possible. And then in red, I'm going to showcase kind of what you would do if you were just doing the math. Again, the instructions say to rewrite first, not simplify first. So let me rewrite. I'm going to take this parentheses. I'm going to use the associative property, which states that I can rearrange the parentheses in different orders because there's the same operation between them. We have a plus sign here and a plus sign there. So I'm going to do 5 plus 8 plus negative 8. These two are equivalent statements. In this case, I've used the associative property to do it. Now, 8 plus negative 8, you'll notice, is the inverse property. 8 plus a negative 8 is 0. So this becomes 5 plus 0, which is, of course, 5. If you were just doing the math directly, you would get the exact same result. But again, this helps to train your brain when it comes to variables later on. It's very important to be able to see that this is always a possibility. And so if I was just doing the math, 5 plus 8 is 13. 13 plus negative 8 is 5. And so we do get the same solution. Like, that doesn't change. It never changes. That's why we have things like order of operations, is we should always get the same answer. And so these properties are an extension of order of operations, where I'm allowed to do these steps if it would make the problem easier. For many of the problems tonight that are like this, it may not make them any easier. That doesn't mean it's not allowed. So, C. Let's go with 6 minus 15 plus 9. Okay. For this problem, I want to note something very specific here. When it comes to it, subtraction and addition are essentially the same thing. If you don't understand what that means, I want to introduce you to a very simple problem. And it's actually something we did up here. If I tell you 13 plus negative 8, we should all agree the solution is 5. But do we all agree that this is equivalent to 13 minus 8? And that, in fact, we could go back and forth between these two. We could rewrite 13 minus 8 as 13 plus negative 8. We could write 13 plus negative 8 as 13 minus 8. These two are equivalent statements. However, if you look at this problem, you might notice that there's a subtraction sign here. But we could view the subtraction sign as instead an addition sign, much like we did here. Because these two are equivalent. They have the same properties. And so when we do these problems, you can choose to rewrite these as 6 minus 15 plus 9 using the associative property. 6 minus 15 is negative 9. Negative 9 plus 9, according to the inverse property, is 0. Would you get that same result the basic way? Of course. 6 minus 15 plus 9. 15 plus 9 is 24. Ooh. So what happened here? If we do it this way, or we do it the more direct way, we would instead get 6 minus 24, which is negative 18. This tells me that there's been a failure. Because remember, if we do order of operations correctly, we should all get the same answer. And this leads us to our last property. Okay? The distributive property. That has to be done when looking at these problems. We cannot take this step, 6 minus 15. We can't merge these two. Remember, we have to do the exact same operation. And so if we distributed instead, from here, we could have gotten 6 minus 15. Distribute the negative to both pieces, so 6 minus 15, and then minus 9. This would be the correct step. This process does not work. Because again, they have to be written as the same operation. That plus sign, yeah, you can do it with a single number, but because there's stuff in the parentheses, remember, order of operations, parentheses has to come first. So if you want to get parentheses, you either have to simplify what's inside and get 24, or distribute and get our negative 18 that way. Again, when it comes to parentheses, you either need to distribute to simplify it, or directly simplify it. I can either distribute the negative and make this negative 15 and negative 9, or I could simplify the 15 and the 9 to get 24. That will cause me to get the same answer. And that's how I know it's right. This process isn't right, because it doesn't follow our rules. When there's parentheses, you have to either choose to distribute, as is done here, or you have to choose to simplify. This is how we do it. Alright, I've officially gone 3 minutes over. I owe you 3 minutes of time. Again, we're starting off pretty basic. Your homework will be posted in paper form. It'll probably be a PDF, or a PDF I should say. And that'll be concluding for today. Hope you guys have a great Tuesday. I'll talk to you guys tomorrow, where we'll talk about some algebraic operations. Taking more and more steps forward. And again, this first week should be largely review, so don't feel too bad if you feel like this is easy. Hopefully enjoy it that way you can. Alright, see you guys later.